Let x and y be jointly normal. The mu and the sigma are given here. There are three questions. Find this probability and find a constant A so that these two are independent, and find this conditional probability A. Let's first calculate the covariance of x and y. This is equal to rho sigma x sigma y, and rho is equal to -1/2. Sigma x is 1 and sigma y is 2 because the sigma y squared is 4. So this is equal to -1/2 times 1 times 2 equal to -1. So now let's calculate the probability of x plus y is greater than 0, and let z equals x plus y. And one feature of joint normal distribution is that any linear combination of them is still normal. So z is normal. To calculate this, let's first calculate the mean and the variance of z. The mean of z is equal to expected value for x plus expected value of y, which is equal to mu x is 0, mu y is -1, so this is -1. The variance of z is equal to the variance of x plus the variance of y plus 2 times the covariance of x and y. So this is equal to variance of x is sigma x squared, this is 1, plus variance of y is sigma y squared, which is equal to 4, and plus 2 times the covariance of x and y, which is calculate that, is -1, so this 2 times -1, this is equal to 3. So now we have the mean of z is -1, the variance of z is 3. Well, we're ready to calculate this one. So the probability of z is greater than 0 is equal to 1 minus probability z less than or equal to 0. So this is equal to 1 minus probability z minus mu z divided by sigma z less than 0 minus mu z divided by sigma z. So the reason we do this is that if we subtract the mean and divide the standard deviation, this will become a standard normal distribution. So we basically take this and we subtract mu and divide it by sigma on both sides, so we get this. And now this is a standard normal, so we can write this as 1 minus. So this is just the distribution function of standard normal. So this is equal to 1 minus, and we just calculate the mu z is -1. So this is 0 minus -1, and sigma z is square root of 3 because the variance of z is 3. So this is the square root of 3. And this is equal to 0.28. Okay, let's look at B. So B is to find a constant so that these two are independent. One feature of a joint normal distribution is that any linear combinations of them are still joint normal. Another feature of joint normal distribution is that if the correlation is 0, then they are independent. This is not true for in general. So if the correlation or covariance or the covariance of the two variables is 0, it doesn't mean that they're independent. But for normal distribution, it's true. So if the covariance of the two variables are 0, then they are independent. So we only need to find a constant A so that the covariance of these two variables are 0. So let's calculate the covariance. The covariance of ax plus y, x plus 2y is equal to a covariance x plus a 2a covariance xy plus the covariance xy plus 2 covariance y and y. So the first one, the covariance xx is just a sigma x squared, which is 1. So this, the second item, if you combine these two, this is basically 2a plus 1 covariance xy plus the 2 covariance y is just sigma y squared, which is a 4. So this is 2 times 4. And this is equal to a plus 2a plus 1. The covariance of x and y, we calculate that. That's -1. So this -1 plus 8. So this is equal to -a plus 7. So for these two variables to be independent, the covariance must be 0. So this is equal to 0. So a equals 7. So that's it. Part C, find this conditional probability. Let u equals x plus y, v equals 2x minus y. We know that if x and y are joint normal, any linear combinations are also joint normal. So let's first figure out the joint distribution of u and v. So expected value of u is equal to -1. The variance of u is equal to 3. The expected value of v is equal to 1. The variance of v is equal to 12. We won't write down the details because it's pretty straightforward. So because both u and v are just a linear combination of x and y, we can easily calculate the mean and the variance. And let's calculate to get the joint distribution, we also need to calculate the correlation between u and v. Let's first calculate the covariance. The covariance of u and v is equal to -3. It's the same as we calculate the covariance of ax plus y and x plus 2y. I want to get into the details. So the correlation of u and v is equal to the covariance of u and v divided by sigma u and sigma v. And this is equal to, so the variance of u is 3, so the sigma u is square root of 3, and the variance of v is 12, so sigma v is square root of 12. So this is equal to -1/2. So now what we try to calculate is the probability of u is greater than 0 and v is 0. We know that now u and v are joint normal distribution, and we have a theorem here basically says that if x and y are jointly normal and the y is normal distribution given x equals x, so and the distribution of y for x given x is normal with the mean given by this formula and the variance given by this formula. So based on this theorem, because u and v are joint normal distribution, so given v equals 0, u is normal distribution, and we can calculate the mean and the variance of this normal distribution using this formula. So basically, the expected value of u given v equals 0 is equal to the mean of u plus rho uv times sigma u times 0 minus the mu of v divided by sigma of v. So this is -3/4. The variance of u given v equals 0, again, use this formula. So this is equal to rho 1 minus rho uv square sigma u square. And this is equal to 9/4. So these two are just calculated using these formulas by plugging in all the relevant numbers we already calculated. For example, the rho here, rho u and v, we already calculated is -1/2. All the other quantities is already known based on what we have calculated. So now the probability of u is greater than 0, v is equal to 0, can be calculated as 1 minus p. U is less than or equal to 0, v equals 0. So this is equal to 1 minus probability u minus -3/4 divided by 3 over 2 less than 0 minus 3 over 4 divided by 3 over 2. So let me explain. So basically, we try to calculate this. Sorry, has to be conditional v equals 0. So because we know that the conditional v equal to 0, and u is a normal distribution with a mean given by negative 3 over 4, and the variance given by 9 over 4, or the standard deviations is given by 3 over 2. So if we subtract the mean, u subtract the mean divided by standard deviation on both sides of this, 0 minus the mean and divided by standard deviation. So this just subtract the mean of u and divided by the standard deviation of u on both sides. And we know that given v equals 0, u is a normal distribution. When you subtract the mean divided by standard deviation, this whole thing is a standard normal distribution. So now we can write down this using the standard normal distribution function. So this is 1 minus phi 0 minus negative 3 over 4 divided by 3 over 2. So this is equal to 0.31. Thank you for watching.